Hi, James here. Today we're going to look at Maxima and Minima. I'm going to lay out some rules that you can follow to solve any problem concerning Maxima and Minima. Of course, not the application of Maxima and Minima because we're going to talk about that in the next video, but just to find the critical points and then to find the Maxima and Minima. Right? When you are given an equation, you are given a function, say f of x, alright, the first thing you need to see, you need to look at the function whether you can find the critical points. The critical points are simply the values of x in a given function. So to find the critical points, your equation should be in quadratic form so that you can find the factors and then find the critical points. If it is not already in quadratic form, you can do that by finding the first derivative. Let's say you find f prime of x and then you equate that to 0, and from there you can find the critical points. And after finding the critical points, you can proceed to find the maxima and minima. And the next step is to find the second derivative of your function. You can say f prime of x, and then you equate it to 0 again, and then you plug in the critical points that you found in the first derivative. Alright, say you found x is a and v. Alright, because in a quadratic formula you are always going to find two values of x. Alright, then first you plug in a, the first value of x, in your second derivative. You're going to either find maximum or minimum, and then you plug in the second value of x, which in this case is v, and you're going to find your maximum or minimum. So when f prime of x on the second derivative of your function is greater than 0, that is minimum. Alright, but when your second function is less than 0, that is maximum. And as you can see here, any number that is less than 0 is always going to be a negative number. Alright, and any number greater than 0 is always on the positive side. So it means that your maximum is always going to be negative and your minimum is always going to be positive. So the easiest way to remember this is whenever you have found a positive number, remember that is a minimum. And whenever you have found a negative number, that is a maximum. Alright? But when f prime of x, which is your second derivative, is equal to 0, then you do not have a maximum or minimum. Neither of them is there. So you have to proceed to find maximum or minimum. And the way to do that is to find the third derivative of your function. And perhaps you are going to find maximum or minimum. If you don't find it in the third derivative, you can proceed to find the fourth derivative of your function, and so on. Let's do an example on this so we can better understand it. I'll start with a very simple example. Let's say our function is 6x squared minus 30x plus 36. Alright, as you can see in this equation, it's already in a quadratic form. We can find the critical points and immediately at this one we do not need to find the first derivative. So all we need to do, let's isolate 6 because 6 is a common factor here. When you divide this one by 6, this 6 and this 6 will go, and you're going to get x squared 30 by 6 is 5, and then you put your x, plus 36 by 6 is 6. Alright, now you need to find the factors of negative 5 and 6. What numbers can you multiply to give you positive 6, and when you add them they give you negative 5? Alright, I suppose these numbers would be negative 2 and negative 3. Negative 2 times negative 3 is positive 6. Negative 2 minus 3 is negative 5. Alright, because when you say negative 2 plus negative 3, it is just the same as saying negative 2 minus negative 3. So these are our factors. Then it's going to be x minus 2, x minus 3, and we equate it to 0. Alright, finding factors is easy, and you might have come across it in high school. When you open the brackets here, you're going to find this function. It takes you back to the original function. Now we can see that our x values will be 2 and 3. Alright, so from here we can find our second derivative, or the first derivative, because apparently our function was already in the first derivative, I guess. So here we just need to find our first derivative. Our function originally was 6x squared minus 36x plus minus 30x plus 36. Right. Our derivative will be 12 minus 12x minus 30, and then we equate it to 0. When we plug into the first value of x, we are going to get 24 minus 30. 24 minus 30 is negative 6. This is negative. And what did we say about that? Negative 6 is less than 0. That means our function is actually maximum here. Let's plug in 3 to this same equation. So it's going to be 12 times 3 minus 30. 12 times 3 is 36. Minus 30 is going to give you 6. And this one is greater than 0. It implies it is a minimum. Alright, it's so simple. What you need to do is, first of all, see if your equation is in quadratic form. And we are lucky here that this equation is in quadratic form. We do not need to find the derivative. So we immediately find the critical points. And we have found our critical points here. X is 2 and x is 3. And then we find the second derivative, but in this case it's our first derivative. We find the derivative after finding critical points, and then we plug in the values of x. First we take the first value and it gives us our answer. In this case we got our answer as a maxima, and then we plug in again another value of x and we find another answer. Let's do another example so it can sink in. Let's take this function f of x is x to the 5th minus 5x to the 4th plus 5x to the 3rd minus 1. It looks like we need to do a little bit of work in this equation. We need to find the first derivative. The first derivative will be f prime of x will be 5x to the 4th minus 20x to the 3rd plus 15x squared, and this constant here is going to be 0, so we are going to leave it out. Now let's say f prime of x is 0, so we can equate our function to 0. It's going to be 5x to the 4th minus 20x to the 3rd plus 15x squared. It's going to be 0. Now let's find the critical points. I can see that 5 is a common factor here, so we are going to let's factor out 5x squared. And when we factor out 5x squared this, we are going to remain with x squared minus here we are going to remain with 4x, and here we are going to remain with 3. And then we equate all of that to 0. So 5x squared is going to be 0. And that implies that x is 0. Anything divided by 0 is just 0. And then we have a whole quadratic equation inside the brackets. We're going to equate the whole thing to 0. and we're going to find the points. So what are the factors of -4 and 3? It is -1 and -3. -3 times -1 is going to give you 3. -3 minus 3 is going to give you -4. It gives you +3 and -4. Then our factors are going to be x minus 1 and x minus 3, meaning we are going to get x is 1 and x is 3. And we already have x is 0 here. So we have three points, critical points. Now let's go ahead and find maxima and minima. We need to find the second derivative. From our first derivative, we need to find the second derivative. So f prime of x, which is the second derivative, will be 20 x raised to the power 3 minus 60 x squared plus 30x. Alright, now let's start with 0. Let's plug in 0 here in this equation, because x is equal to 0. It's going to be 20 0 raised to the power 3 minus 60 times 0 raised to the power 2 plus 30 times 0. All of this reduces to 0. That means our second derivative is equal to 0. And we said before, when your second derivative is equal to 0, it implies that there is no maximum or minimum there. It's neither of them. So let's try x is equal to 1. It's going to be 20 1 raised to the power 3 minus 60 1 raised to the power 2 plus 30 times 1. It will be 20 minus 60 plus 30. 20 minus 60 is -40 plus 30, which is -10. That means when x is 1, our second derivative yields a result of -10. Now let's look at it when x is 3. What do we get? It's going to be 20 times 3 raised to the power 3 minus 60 times 3 raised to the power 2 plus 30 times 3. So 3 raised to the power 3 is 27 times 20 is 540. Alright, it's going to be 540 minus 60 times 3 raised to the power 2. 3 raised to the power 2 is 9 times 60 is also 540. Alright, plus 3 times 30 is 90. And this one goes. So we get 90 here. That means our second derivative is greater than 0 and less than 0 there. This point is a maximum. This one is a minimum. And you can pretty much stop here, but you need to recognize that at point 0 here, our function is stationary. It's neither minimum or maximum. It's just stationary. And because we also have other points, other critical points, we did not have to find the third derivative. We just have to use these critical points. But if it so happens that all your critical points are stationary, you might need to find the third or fourth derivative for you to test actually if you could find the maximum or minimum, or if you could not find that. Thank you for watching. Consider to subscribe, and I'll see you in the next video. In the next video, we are going to talk about the application of maximum and minimum.
And I don't really